Recently, the price of gold has surged. In the last couple of months, it has traded roughly between £2,900 and £3,400 per ounce, the highest levels on record. 5 years ago, it fell close to £1,200 per ounce, and around 20 years ago, it traded near £300 per ounce. For most of human history, gold was used for art, jewelry, and the display of power and wealth. Over time, it became money, first as coins in ancient civilizations, and then as the backbone of entire financial systems. Today, gold appears everywhere in electronics, spacecraft, medicine, food, decoration, and of course, as an investment. But regardless of its social value or market price, gold still is just one thing at its core, a chemical element. So let's step back from the charts and from the vaults and look at what gold actually is, what makes it so unusual, and where it comes from. Gold carries the chemical symbol Au from the Latin aurum, meaning radiance or dawn. On the periodic table, gold is element number 79. This is a crucial number because it tells us that every gold atom has 79 protons in its nucleus. In nature, gold exists entirely as a single stable isotope called gold-197. This means that its nucleus contains 79 protons and 118 neutrons. Because gold atoms are electrically neutral, they are surrounded by 79 electrons, arranged in very specific shells around the nucleus. And it is this precise atomic structure that gives gold its unusual physical and chemical behavior. Gold is classified as a noble metal. It doesn't mean that it's valuable, it means it's chemically unreactive. Have you not noticed that when you have gold jewelry or something gold, it doesn't tarnish over time? Gold does not react with oxygen, with water, or with most acids. Compared to other elements like iron, reacts with oxygen and rusts, or copper, which also slowly oxidizes and turns green. However, gold stays gold. This chemical reluctance comes from its electron structure. To make gold bond with other elements, for example, we create rose gold by bonding gold with copper, or white gold is a mixture of gold and palladium. We have to force it to do so under controlled conditions to create these alloys. Gold is also a transition metal. The arrangement of electrons around the atom's nucleus gives gold remarkable properties. It's an excellent conductor of electricity, which is why it's used a lot in electronics. At very small scales, gold can also act as a powerful catalyst. These are not intuitive properties, they emerge directly from electron behavior. Gold is quite malleable, so when you have solid objects like we can see rings or bars of gold, that means there are trillions of gold atoms packed tightly together in a repeating crystal lattice. It is this structure that makes gold dense but also allows it to be hammered into very, very thin sheets like gold leaf. Gold is not made on Earth, it's not made in the sun. It was created far out in space and long before our planet existed. Inside stars, nuclear fusion builds elements up step by step, small atoms fusing into larger ones, and then they release energy. However, in a dying star, this process stops at iron. To make elements heavier than iron, including gold, the universe needs extreme and violent conditions. So when a massive star dies, it collapses and explodes as a supernova. This is where the heavier elements are created in outer space, including gold, and then it is blasted out into space. However, the main source of gold creation in the universe actually comes from a neutron star collision. So after this massive star collapses, it can form a neutron star. And sometimes two neutron stars collide together in space. When this happens, matter is torn apart. There is an immense degree of pressure and heat, and observations have shown that these collisions produce enormous amounts of gold and other heavy elements. Once the gold has formed, gold atoms drift through space and they become part of gas clouds that eventually form new stars, planets, and solar systems. So Earth formed around 4.5 billion years ago through a process called accretion, where dust and rock gradually clumped together under gravity. So the early Earth was molten rock, and the heavier elements, with iron and including gold, they sank towards the core, which is why we have an iron core at the center of the planet, and the lighter materials rose towards the surface, which is why we have a rocky crust. If that was the whole story, however, most of Earth's gold would be locked far beneath us and well beyond our reach. But early Earth endured long periods of external bombardment from asteroids and meteorites, especially during the Hadean and early Archean eons. Some of these impacts would have delivered fresh material from space, including gold and other heavy metals. So much of the gold that we mine today most likely came from this bombardment, as we can't reach that far deep into Earth to get that old gold out. So any gold that you see or own today is billions of years old. It was forged in outer space, stellar catastrophes under immense heat and pressure, scattered across space, and then brought together on Earth, long before humans ever gave it the price of what we have today, between 2,900 and 3,400 per ounce.